Hello and welcome to PCI TV. Today's demonstration is going to be on using multiple images over the same location collected from UAVs to perform change detection. We have a data set that's been collected over an area of interest using a Phantom 3 Professional. As you can see, using the Phantom 3 Professional, we're able to fly the same area over and over again. And in this particular case, we have several data sets collected over the period of roughly a month and a half. And one of the things that we want to achieve is automatic feature extraction from these data sets. Now, these data sets were processed using structure for motion technology. And this technology is really revolutionary because we're able to produce something from the imagery even though the quality of the instrumentation on board the UAVs is not at the same level as more professional cameras that are available in the marketplace. These are really relatively inexpensive UAVs costing anywhere between $1,500 to $2,500. So for something really inexpensive and structure for motion technology, we're able to generate a map. Now, one of the issues that we've noticed with this type of data is although we're able to produce an orthomosaic, if we want to automatically extract features, we will have to achieve a really high degree of co-registration accuracy. That's step number one and is absolutely critical for performing automatic change detection. Now, if we notice here, we've drawn some linear features on the September 21st image, and when we compare the alignment of the September 21st image to the August 16th image, we have a displacement. Now, the reason for that is we haven't collected any ground control on both data sets. We've actually processed, they've been processed independently using structure for motion technology, and so when we bring the imagery into an image analysis package such as Geomatica, we really won't be able to perform any change detection here because the changes we'll observe, of course, will be related to the displacement in the data sets. Now, technology exists within Geomatica to automatically co-register these data sets to each other. We can either select a reference data set or we can choose one of the base images to be used as a base layer. Now, these data sets have actually been co-registered to each other, and we've picked the first date as our reference image. And as you can see, if I toggle these layers on and off, I'll just start taking them off one by one. So August 15th is our first date. If I turn that one off, August 16th is underneath it. It lines up perfectly. So you can notice the roads are lining up, and the only changes that you're seeing are actually related to the changes on the ground. You can see that the vegetation in this case is decreasing over time. So as we're getting later in the growing season, a lot of these plants are being pulled out or harvested, and all we're seeing are the changes related to the agriculture as opposed to changes in the misregistration. So once we have pixel perfect alignment, we can then perform some analysis. So here I'll toggle these two images on and off, and you'll see what I mean. So from one date to the next, from August 15th to August 23rd, we had quite a few changes here. Visually, it's a little bit difficult to see those changes, so what we want to do is automatically extract those features. We can see some changes over here. Obviously, this large change in the middle of the image. But if I turn on the actual final product, you'll see that there's quite a few changes that are occurring. So all of these polygons here are representing areas of significant change. So for these data sets, we don't have a near infrared channel. We only have visible bands, RGB. So we are restricted in terms of what we can do for vegetation analysis. However, we can perform a simple green-red vegetation index. So if I turn on August 15th, and then I turn on August 23rd on top of that, you'll see visually again that there are changes. We can then perform a change detection on those two vegetation indices and derive a change layer. So what we see here are areas that are green, that are bright, are actually high degree of change, and the areas that are blue are low degree of change. Now we have a lot of small change, which is maybe not what we're interested in. So we can actually specify when we extract the changes the number of polygons that we want to retain. So if we're trying to get a actual parcel, we can specify the size of change that we want to keep. So we're able to then use another algorithm within Geomatica to perfectly extract the changes within an area of interest. So if I want to find out exactly what is the surface area related to this particular polygon, I actually have a calculation here in terms of square meters in this case. So I know exactly how much change has occurred there. So obviously that's very useful information that can be used for decision making. And again, the whole process can be completely automated and really wouldn't be possible unless we had pixel perfect alignment from the multiple images over time.